أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على رسول الكريم وعلى آله وصحبه وسلم. We thank Allah subhanahu wa ta'ala, the uncreated creator, the one who taught men by pen. We ask Allah to bless the soul of our Prophet Muhammad sallallahu alaihi wasallam. May Allah bless his household, his companions, and the generality of Muslim Ummah to the day of accountability. Allahumma Ameen. Here comes another lessons in the series of our lessons that we have in this third term work at Chy Model College, Ibadan, Oyo State, Nigeria. This lesson is for chemistry, SS2, week 9. So this is the first part of the lesson of the week 9. So actually the note here covers lesson 1 and 2, but the first aspect of the lesson, which is lesson 1, is what we shall discuss here in the first place. Then later on we'll also talk about the other aspect, which is the second lesson. The notes is as presented by Master Chm2 Ridwan Babatunde and Master Abdulatif Mansour. It is a continuation of where we stopped at the topic we discussed. The topic we talked about on 8th week, sulfur and its compounds. So this is the other part of the sulfur and its compound. We shall continue from sulfur 6 oxide. Sulfur 6 oxide. Before now, we have looked at sulfur, how it can be extracted. So we have looked at some other compounds of sulfur, like the hydrogen sulfides. We have looked at its physical property, its chemical properties, and the likes. We have looked at the allotropes of sulfur. We have looked at the different reactions that this can undergo. So we have also talked about the sulfur 4 oxide itself. But today we shall continue to look at another compound of sulfur, which is sulfur 6 oxide. Sulfur 6 oxide, as it is, we should know that under normal condition, this sulfur 6 oxide, it doesn't readily combine with oxygen to form sulfur 6. This sulfur 4 oxide rather, that is SO2. It is actually used to form sulfur 6 oxide that we are talking about here. But it does not readily combine with oxygen, that you just take SO2 and O2 and you form your sulfur 6 oxide like that. No. That is why we say that under normal condition, it doesn't combine. But if you want to get a very good yield of this compound, there are some conditions you need to take into considerations. First and foremost, a catalyst like platinized asbestos of vanadium 5 oxide. You make sure the reaction takes place under a slight pressure and a temperature of 400 to 450 degrees Celsius are required. How is it prepared in the laboratory? That is a preparation of sulfur 6 oxide. It is prepared in laboratory as follows. Sulfur 6 oxide, you are going to have a mixture of sulfur 4 oxide and oxygen. It's first dried by passing it through concentrated tetrasulfate 6 acid. Then the gaseous mixture is passed over a strongly heated catalyst. Sulfur 4 oxide formed. The sulfur 6 oxide formed is seen as dense white film and solidified when cooled in the freezing mixture of ice and salts. It can also be obtained by dehydrating tetrasulfate 6 acid with phosphorus 5 oxide, or by heating some tetrasulfate 6 or hydrogen tetrasulfate 6. The diagram here is showing the simple analysis that we have made above. We have sulfur 4 oxide and oxygen entering into these two delivery tubes, and they are passed over concentrated tetrasulfate acid. You're going to have sulfur 6 oxide being liberated, and it's passed through platinized asbestos of vanadium 5 oxide. When it is now passed through this, you're going to have your sulfur 6 oxide inside ice, mixture of ice and salt. Where we have the freezing mixture, it contains the ice and salt. Then that is your pure form of the sulfur 6 oxide. Moving forward, what are the properties of sulfur 6 oxide? It exists as a white needle-shaped crystal at room temperature. It has a low boiling point 45 degrees Celsius. It is an anhydride of tetraoxosulfate acid which dissolves in water to form tetraoxosulfate acid. So looking at this reaction below, H2O plus SO3, you're going to have H2SO4. It is actually a reversible reaction. Number 4, it dissolves in concentrated tetraoxosulfate acid to form oleum or fuming tetraoxosulfate acid. Another name for oleum is fuming tetraoxosulfate acid. So that is, you have SO3 plus H2SO4 giving us H2H2O7. It's also a reversible reaction. Trioxosulfate 4 acid, another compound of sulfur. This compound of sulfur is an unstable and it is formed when sulfur 4 oxide dissolves in water. It takes place in a reversible reaction whereby you have SO2 plus H2O, you have H2SO3. The acid is basic and it ionizes as follows, meaning that it can release 2 moles of protons, as you have in these equations below. H2SO3 will first get ionized, releasing 1 proton, so the other one can further ionize and give you another proton. That's why it is said to be dibasic. It is prepared by dissolving sulfur 4 oxide formed from gently heated mixture of HCl and Na2SO3 in water. What are the physical properties of this acid? It is a colorless and unstable acid. It smells strongly of SO2, which is a product of its decomposition. It turns blue litmus red because it's an acid. Chemical properties. Action of air. When trioxosulfate 4 acid reacts with air, it gives us H2SO4, tetraoxosulfate acid. So it becomes oxidized by atmospheric oxygen. Number 2, trioxosulfate 4 acid is responsible for all the reducing and bleaching action of sulfur 4 oxide. When we say sulfur 4 oxide bleaches, it actually bleaches by reduction, right? But the main action of this sulfur oxide bleaching is due to the fact that it has formed an acid that we call trioxosulfate 4 acid. Number 3, if it should be considered as an acid, this trioxosulfate 4 acid, it forms both acid and normal salt with alkalis. That is when it reacts with sodium hydroxide. It now depends on the amount of the alkalis present. For instance, if the alkalis is in limited supply, you are going to have acid salt being formed. But if it is in excess supply, you are going to have a normal salt being formed, as you can see in these equations. Uses of trioxosulfate 4 acid. It is used for bleaching straw and other fabrics. It is also used as a germicide. Now, another compound, trioxosulfate 4. Trioxosulfate 4. These are the normal salts formed when trioxosulfate 4 acid or sulfur 4 oxide reacts with an excess of alkalis. How are they prepared? The trioxosulfate 4. These salts, they can be prepared by neutralization. If you have sulfur 4 oxide reacting with sodium hydroxide, you are going to have Na2SO3 plus H2O. So this Na2SO3 is an example of trioxosulfate 4. This is sodium trioxosulfate 4. Or you have H2SO3 plus 2KOH, you have K2SO3 plus 2H2O. This is potassium trioxosulfate 4. Another way of its preparation or of their preparation is by precipitation. Insoluble trioxosulfate 4 are precipitated out of solution when sulfur 4 oxide is bubbled through a solution of a corresponding metallic salt. By precipitation, it is used for insoluble trioxosulfate 4, meaning that we have some trioxosulfate 4 that are soluble, those that are some that are insoluble. Now, properties of trioxosulfate 4. The trioxosulfate 4 of ammonia, of potassium, of sodium and calcium are soluble, while the other metallic trioxosulfates are insoluble in water. They release sulfur 4 oxide when heated with concentrated or dilute acids. That is, we have calcium triosulfate 4 plus 2HCl, giving us calcium chloride plus H2O plus SO2. Number 3, they are slowly converted to the tetrasulfate 6 by air and are more rapidly by many oxidizing agents. Number 4, triosulfates 4 in dilute acidified solution have the same reducing power as trioxosulfate 4 acid. Moving forward, how do you test for triosulfate 4? On warming with an acid, if sulfur oxide is released when an unknown substance is warmed with a dilute acid, then a trioxosulfate 4 is present. A trioxosulfate 4 is present. It's not actually trioxosulfate 4 is present. As you can see in this equation. Another way by which you can test for it is with barium trioxonitrate 5. A white precipitate of barium triosulfate 4 will be formed in the presence of triosulfate 4. That is, the precipitate dissolves in dilute HNO3 with the evolution of SO2. If you have barium trioxonitrate 5 reacting with a particular solution containing triosulfate 4, so we are going to have barium trioxosulfate 4 being formed. That is the white precipitate. The precipitate which in dilute HNO3 will lead to the resolution of what? Resolution of SO2. So we should know that all these are also compounds of sulfur. So inshallah, we will stop here for today and we shall continue from there next lesson. So far so good. As far as today's lesson is concerned, we have been able to look at the sulfur 6 oxide, how it can be prepared. We have emphasized the fact that it is not easily prepared by just reacting sulfur 4 oxide with oxygen. No. So, but some conditions must be set aside before it can be achieved. This particular step that we are talking about here in this diagram is a very important step in the contact process when we get to the preparation of tetrasulfate 6 acid by contact process, which we shall look at when we get to the next lesson in this week 9 topic. I pray Allah subhanahu wa ta'ala grant us the knowledge, wisdom, and understanding. May Allah save us from every calamity. Fassalamu alaikum wa rahmatullahi ta'ala wa barakatuh.